simplify the integral of arctan of x. Okay? So what have we got here? We just have some function, right? We're just integrating some function all on its own. And so you can kind of stop and say, well, where do you go from here? I don't know how to integrate arctan by itself, and yet that's kind of what I need. I just need to find an antiderivative of arctan, and then I'm done. But I don't have that familiarity. I've never seen such and such has a derivative of arctan. So, what do we do? Right? What do we do with something like this? Because we're just trying to integrate a single function by itself. There doesn't appear to be anything. But a great thing we can do is we can apply integration by parts in a sort of sneaky way. And you say, hold on, integration by parts, don't you need a product in there? You know, some function times the derivative of another function? Where are you going with that? So we need sort of two functions if we're going to use integration by parts. So I seem a little crazy here, but what we can do is we can use sort of a sneaky one. Every expression everywhere can always secretly have a 0 added to it without really changing it, or a 1 multiplied by it. So that's what we're going to do. We're going to rewrite this as 1 times arctan of x dx. And now I've got a product here. Right? And now I can use something like integration by parts. So integration by parts is great when you have just sort of a lone function sitting there, like arctan or really any of the arctrig functions, or lots of inverse functions work this way. Okay? So now that I've got the product, now that I've decided I'm going to use integration by parts, I have to say, well, what's going to be my u, what's going to be my dv? Now, if I were to do something, and we've got two choices here, right? We can have our u be 1 and our dv be arctan. Right? That's an option. I got two functions. I choose. So if my u is 1, the derivative of that is just 0. Okay, that's not bad. If my dv is arctan, technically I should be writing arctan dx here. Technically this should be 0 dx, but no one writes that. But if dv is arctan, then what would v be? V would be something that gives me arctan as a derivative, and that's kind of what we're trying to find. So this won't work. So, okay, then that must mean we switch it around. U should be arctan, and the 1 that we introduced should be my derivative. Technically, this should be 1 dx, and you could just write dx as well. Okay? But this works out a little bit, because what's the derivative of arctan? 1 over 1 plus x squared. Pretty common one to know. And then, can I think of an antiderivative for 1? Yeah, x. X works great. So we can apply integration by parts here. So we introduce another function so that we've got two functions, and then we just have to carefully pick. Okay? But we can't have arctan be our dv because, well, if we could, we would know our v, and then we wouldn't need to integrate arctan. We would just write down an antiderivative, and we'd be all set. Okay. So let's continue on. So what does integration by parts do? It doesn't solve the question for us. It just allows us to rewrite. So we'll get u times v. I think I have those switched around. Arctan is the u, and x is the v. Minus the integral of, and now it'll be v, and then the derivative, the du here. Okay. So x times arctan, nice function, minus, and then we got to focus on this integral here. So let's just sort of section off a piece of paper here, and we have x over 1 plus x squared dx. And if I could integrate that, then we're done. And this turns into something plus a constant. So what can we do here? Well, here's where a substitution might help us. Right? How do you know it's a substitution? Well, notice that the denominator is a quadratic. The numerator is nice and linear. So if I were to try a substitution like, I could say let u, but we already had a u before, so let's use a different variable. Let's say let w. Okay, let w be 1 plus x squared. dw by dx would be 2x, and so I can rearrange that and say dx is going to be dw by 2x. Okay, so we do our substitution, the w here, x up here, dx turns into dw over 2x. The x's cancel out. left with 1/2 integral of 1 over w dw, but we know how to integrate the reciprocal function. So we get ln absolute value of w, and what was w again? 1 plus x squared. So we get ln absolute value 1 plus x squared plus c, and so that finishes that off, and we can put this all together and say, arctan of x dx, we get x times our function minus 1/2 ln absolute value 1 plus x squared plus c. And there we go.